Hi guys, welcome back to Research Methods. So hope you had a good Easter. Today we're going to be focusing on tests for differences when we've got three or more groups. So if you recall previously we looked at tests for differences when we just have two groups. So for example a data set where we've got samples taken before an event and after an event. But this time we've got more sample data sets. So we could have, for example, before an event, during an event, and after an event. Okay, so we can have three or more sample sets. Okay. So this is basically an extension to the previous session. It's important to know that the same principles apply to test for differences on three or more groups as they did when we had two groups. So as always, there are two different pathways that we can take with our data when we come to analysing it. And we can analysing it using a parametric statistics test or a non-parametric statistics test. So in this case, the parametric statistics test is called an ANOVA. That's an analysis of variance. And the non-parametric statistics test is either going to be called a Kruskal-Wallis or a Friedman. Now, whether or not we use a Kruskal-Wallis or a Friedman depends on whether our data are independent samples data or paired samples data. So last time we looked at paired samples data. Okay, so for example, as I said earlier, before versus after. But this time we're going to be looking at independent samples data. So where the data come from sample data sets which aren't related with each other. Okay, so we could, for example, perform a treatment on one sample set of individuals, and we can perform a different treatment on a different sample set of individuals. Okay, so in this case, if we're looking at independent samples data, the non-parametric statistics test would be the Kruskal-Wallis. The Friedman is the paired sample. And as before, the parametric statistics test has certain assumptions linked to it. So if you remember, parametric statistics use means, therefore it's a requirement of this statistics, these types of statistics, that the data are normally distributed, so we don't have any outliers in there. And the non-parametric statistics test uses medians. So these assumptions do not need to be met. Okay, it doesn't matter if we've got outliers. So if we've got outliers, we use a non-parametric stats test. So today we're going to look at a few different things. So we're going to look at how to set your data up correctly, because the way we set data up when we've got independent samples is different compared to when we've got paired samples. We're going to look at how to perform an ANOVA, and then if there's time you can apply this knowledge to your assignment. Okay, so guys, if you now open up the Excel datasheet that you'll find on Moodle, you'll see a data set that looks a little bit like this, or exactly the same as this actually. Alright, so this is how we would have set our data up beforehand when we had paired samples data. Alright, so it represents in the columns the different variable categories, and in the rows each individual from which we've collected data. Okay, but what we're going to see today is we're going to set the columns up slightly differently for independent samples data. Okay, but we're still going to maintain this concept that the rows represent each individual. Okay, so rows represent the data which come from each individual that we're interested in analysing. Okay, now we can use this exact data set here. We're just going to chop it and change it around a little bit to look slightly differently. So let's just have a look at what we've got. So we've got S1, S2 and S3. So what we're going to say these are then are physiological sample 1, physiological sample 2 and physiological sample 3. Okay, so in this case here, the way that it's set up is individual 1 had a physiological sample taken, say at time point 1, at time point 2 and time point 3, and so forth and so on. Okay, but what we're going to do now is change this data set up so that physiological sample 1 comes from these 6 individuals. Okay, physiological sample 2 will come from another set of individuals, And physiological sample 3 will come from a further set of individuals again. Okay, so first of all, let's just add some more individuals in here. So let's go individual 7, individual 8, individual 9, individual 10, individual 11, individual 12. Okay, so now we've got 6 more samples in here. All right, actually, we can just click on this and drag down, and it'll give us some more. So if you highlight a few of them, and then click on this little thing and drag it down, it will then give us some more samples underneath that as well. So what we want to go to is 18. Okay, we've got 18 individuals from which we've collected data. Okay, now if we copy this data from physiological sample 2, so just highlight it and then press Ctrl X. Okay, and then highlight this cell where you want to paste it and press Ctrl V. Okay, and then we'll do the same for this physiological sample type 3. Okay, and we'll paste that down here. Sorry, so Ctrl X and then Ctrl V. Okay, and then what we need to do is we need to then tell our data set here that individual 1, 2, 3, 4, 5 and 6 are data collected from physiological sample 1. Next 6 individuals at sample 2, and the last 6 individuals at sample 3. Okay, and then we can just change our headings a little bit up here, so we can call this PS, physiological sample. Sorry. This would be treatment, and this would just be the data. Okay. So this is how we would set our data up if we've got independent samples data. Okay. So as I said before, we've now changed up the way that we've represented the columns a little bit. Okay. But we've maintained that concept of rows representing each individual from which we've collected data. Okay, so in this row we've got individual 1 and some data for physiological sample 1. Here we've got individual 2, 3, 4, 5, 6. Okay, so all of these individuals here we collected physiological sample type 1. Okay, in all these 6 individuals here we collected physiological sample type 2, and in these 6 individuals here we collected physiological sample type 3. Okay, doesn't matter what type of physiological sample this is just a made up data set essentially. Okay, just working with numbers. What we basically want to do when we want to do a test for differences then is we want to see if there's a difference between physiological sample type 1, sample type 2 and sample type 3. Okay, but all of these samples were taken from different population sample sets. We're almost ready to put this data into SPSS, but there's still one more thing we need to do before we can do that. Okay, so if you remember, SPSS doesn't like letters, words. Okay, it only recognizes numbers. So basically what we want to do is in another column here, okay, it's still called treatment, but we just want to give S1 1s, S2 2s and S3 3s. Okay, and it'll become clear why we do this in a minute. Okay, and what we're going to do with this later. All right, so we can now put this data into SPSS. So there's only 2 columns we're actually interested to copy into SPSS. So it'll be the actual data. Okay, remember, don't copy in headings. We just want the actual data. So the data collected from the physiological sample types. So Control C, and I'm going to open up a new data sheet. Okay, and copy that into my first column. Sometimes takes a while. Try that. Okay, cool. And then we want this treatment column where we've given it the numbers. Okay, so that's our data now put into SPSS. Now what we can do is select our variable components in this data set. So if we switch to data variable view, first of all we can give our variables names. So let's just call this one data again and call this one treatment. Okay, we need to select the measure. So our data are scale data. Okay, so the actual physiological samples we've collected are scale data. They're numbers and they have decimal places. But our other column is actually nominal data. Okay, because these are categories. All right, so if you look at the way we set this up over here, all right, so individual sample 1, okay, this is the data taken from that individual, but the treatment conducted on that individual is part of a category. So it's category 1, here we've got category 2, and here we've got category 3. Okay, so we need to tell SPSS that these are actually categories. Okay, and then there's one more thing we need to do in here as well. We need to, for these categories, give them some labels. Okay, so this is now kind of linking back to what our Excel sheet looked like a minute ago effectively. So value 1, that was physiological sample 1. Okay, and then if you just click add, that give that value a label. Value 2 is physiological sample 2. Value 3 is physiological sample 3. So just click add, that'll go into there as well. Okay, so if we didn't do this beforehand, if we just put them in as sample 1, sample 2 and sample 3, SPSS wouldn't have recognized that. So we needed to put them in as numbers and then give those numbers labels afterwards, like we've done here. Then if you press OK and then switch back to data view, those numbers are no longer numbers and they're now S1, S2 and S3. Okay, if you want to just check that that's actually definitely the case and that's actually definitely what it's done, you can go up to this little thing up the top here and you can toggle between the two. So you press that, it will then show us the 1s, 2s and 3s that we've put in. Press it again, it goes back to the actual labels we've put in. Okay, so that's basically how we set our data up in SPSS to analyse independent samples data. This would be the case whether we've got 2 groups, 3 groups, 4 groups, doesn't really matter. Okay, so if we just had treatment sample 1 and sample 2, that'll be how we collect it. We could have more as well. Okay, so we could have more sample groups where we get more physiological samples from. But in this case, we're just looking at 3. Okay, so hopefully you've done that and you're looking at the same screen as what we're looking at here on your SPSS data sheet. Okay, and then if that's the case, we're then ready to actually perform the first statistics test. Okay, now in order to do this, you're going to need to stop this video and open up the next video for how to perform an ANOVA.